Greetings everyone and welcome to the chemistry program. I am delighted to be here today to discuss this topic. Today I will be discussing the wonderful and marvelous world of chemistry. Today I'm going to talk about electrochemistry. Electrochemistry. Firstly, what about electrochemistry? Electrochemistry divided into two types, galvanic cells and electrolytic cells. Galvanic cells, we will study the primary cells and secondary cells. While electrolytic cells, we will study three important things, which are electroplating, aluminum preparation, purification of minerals. Firstly, what about electrochemistry? What is meant by electrochemistry? Electrochemistry, it is a branch of chemistry that is interested to study the exchange conversion of chemical energy and electrical energy through what? Through oxidation and reduction reaction. Oh, oxidation and reduction reaction. What about oxidation and reduction reaction? Reduction means the process of gaining electrons, while oxidation means the process of losing electrons. Again, reduction means the process of gaining electrons, while oxidation means the process of losing electrons. Oxidation and reduction reaction. What is meant by oxidation and reduction reaction? They are the reactions in which the electrons are transferred from one of the reacting substance to the other during the chemical reaction. For example, Mg plus 2H plus or positive to give Mg power positive 2 plus H2 evolves. What happens in this reaction? Magnesium changes into magnesium positive 2. Magnesium ions carry 2 positive charge after losing 2 electrons, while 2H positive accepts this electron and it changes into hydrogen gas that evolves from this reaction. How can you detect the presence of hydrogen gas from any reaction? How can you detect it? Hydrogen gas burns with a pop sound. Okay. 2Na plus 2H positive to give 2Na positive plus H2 evolves. What happened? Sodium lose 1 electron to form sodium ion. Hydrogen accepts this electron and it changes into hydrogen molecule that evolves. An experiment that demonstrates one of oxidation and reduction reactions. Experiment. Dip a zinc sheet in blue copper sulfate solution. What happened? Dip a zinc sheet in blue copper sulfate solution as we see in this figure. Observations. Red copper metal precipitated on the surface of zinc sheet, and zinc metal dissolves, oxidizes in this solution. If this continued for a long period, the blue color of copper sulfate solution decreases what? And they become colorless, and the dissolution of zinc increases. What about the conclusion? Conclusion, this reaction is a spontaneous redox reaction, takes place without any external effect, spontaneous redox reaction, reduction and oxidation reaction, and they can be expressed by the following equation. Zinc, Zn, plus copper, positive 2, to give Zn positive 2 plus Cu precipitate. Zinc, oxidation. Copper 2, reduction. Why? Zinc lose 2 electrons during this reaction, while copper accepts 2 electrons. Zinc lose 2 electrons, copper accepts 2 electrons. So the number of electrons lost equals the number of electron gain. The meaning of oxidation and reduction reaction means two processes takes place at the same time. and in the opposite direction. Oxidation means loses electron, the element can lose electron and the another element accepts these electrons. The oxidation reduction means losing and accepting electrons. This reaction consists of two half reactions, which are oxidation means the loss of electron. Zinc loses 2 electrons. As we say, zinc changes into Zn positive 2 plus 2 electron. Zinc atom loses 2 electrons and converts into zinc ion. Reduction. What is meant by reduction? Reduction means gaining electron. Gain electrons. The process of gaining electrons, such as copper positive 2 plus 2 electrons to change into copper 0 precipitated. This process called reduction. This process called reduction. Why? Because copper ions accept 2 electrons during this reaction. Copper ion gains 2 electrons and changed into copper atom. Okay? Scientists had succeeded in arranging a system known by galvanic cell, or voltaic cell. Galvanic cell or voltaic cell. Types of electrical conductor. What are the types of electrical conductors? There are 2 types of electrical conductor, which are electronic conductors and electrolytic conductors. Again, electronic conductors and electrolytic conductors. What is the difference? What are the difference between them? Electronic conductors means they are usually solid conductors. They are usually solid conductors, and their electrical current is passed by moving the electron within the material. This conductor conduct electricity through what? Through electrons. Electrons is a carrier of a charge, carry negative charge. The other type is electrolytic conductor. What about electrolytic conductor? Liquid conductors, the electric current is carried out by what? By the movement of ions. The ions are 2 types, hydrated or free. Hydrated ions or free ions. In case of a solution or molten material, hydrated in a solution, while free ions in a molten material. What are the types of electrochemical cells? There are 2 types of electrochemical cells, as we say before, galvanic cells and electrolysis cells or electrolytic cells. Electrolysis or electrolytic cells. Galvanic cells or voltaic cells, electrolysis cells or electrolytic cells. What are the difference between them? Galvanic cells. They are systems in which chemical energy is converted into electrical energy. Chemical energy into electrical energy through what? Through oxidation and reduction reactions that occur spontaneously. Takes place without an external effect, without an external current. While electrolysis cells means they are systems in which electrical energy from an external source, dry cells, used to form oxidation and reduction reactions. This means this reaction is non-spontaneous reaction. What is the difference between spontaneous and non-spontaneous? A spontaneous reaction takes place in a galvanic cell. The redox reaction or oxidation and the reduction reaction takes place spontaneously without an external effect, without an external current. While electrolysis cells, in these cells, it needs a source of electricity. To make its oxidation and reduction reaction. No current, no oxidation and reduction reaction in electrolysis cells. While in a galvanic cell, there is no external source of electricity. No external source of electricity, but this cells is a source of electricity. Is a source of electricity. This electricity, this cells, galvanic cells used to make the reaction in electrolysis cells. The reaction in a galvanic cells used to make the reaction in electrolysis cells. The current that is produced from a galvanic cell used to produce a redox reaction in electrolysis cells. I hope to be understand. Firstly, galvanic cells or voltaic cells. What about galvanic cells or voltaic cells? It consists of two half cells. Their contents are found in isolated container connected together by a salt bridge. The electrons are allowed to pass through an electric wire between the half cells to obtain electric current. The electrons are allowed to pass through from what this electron? From what? From what arises this electron? From the oxidation reaction and moves it to make a reduction reaction. Redox reaction can take place by this process. The electrons are allowed to pass through an electric wire between the half cells to obtain what? Electric current. Electric current. Okay. Resulting from the spontaneous redox reaction. Redox mean reduction and oxidation reaction. Redox mean reduction and oxidation reaction, which happens in the galvanic cell spontaneously. Spontaneously takes place without an external effect. Again, the reaction in a galvanic cell takes place without an external current, an external effect. So this reaction called the spontaneous redox reaction. What happened in galvanic cell that consists of zinc electrode present in zinc sulfate and the copper electrode present in or dipped in copper 2 sulfate. What happened? Zinc moves freely in the solution, as you see, and sulfate moves freely in a solution. It's a carrier charges. It's a carrier charges. While in the other hand, copper ions moves freely. Copper carry 2 positive charge. Sulfate SO4 carry 2 negative charge. And the salt bridge that contains NaCl, KCl, Na2SO4, an inert solution that can't react with the two solutions of the two half cells or the two electrode. Pay attention please again. In a salt bridge, there is a solution. A solution to conduct between two solutions. And this solution must be inert. Copper accept 2 electrons comes from zinc, while zinc zinc lose 2 electrons and it changes into zinc ions. Zinc ions can move freely. Copper precipitated as you see after accepting or gaining 2 electrons. After accepting this copper precipitated as you see after accepting, while zinc increases. Why? Zinc ions increases. Why? Because zinc dissolves, oxidizes and changes into positive ion, zinc positive ion. These ions can move freely, a result of a spontaneous oxidation reduction reaction. The spontaneous oxidation reduction reaction gives an electric current, as we say before. The Daniell cell. Daniell cell is an example of a galvanic cell. Daniell cell. Its structure. Number 1, zinc plate or zinc electrode, Zn electrode, is dipped in a solution of zinc sulfate, which represents anode. Negative electrode. Why negative? Because oxidation takes place at zinc plate, and the zinc is a source of electron. While copper plate, copper electrode is dipped in copper 2 sulfate. The structure zinc in zinc sulfate, copper in copper sulfate. Solution which represents cathode, which represents a positive pole. Zinc negative, copper positive. Galvanic cell consists of 2 electrodes, one of them negative charge and the other positive charge. The negative charge called anode, while the positive charge called cathode. Copper plate or copper electrode is dipped in copper 2 sulfate solution. Cathode, which represents the cathode and the positive pole, while zinc plate is dipped in a solution of zinc sulfate, which represents anode and represents a negative electrode. Okay, be concentrated please and give me your attention. Copper plate, copper electrode is dipped in copper 2 sulfate solution, which represents cathode and the positive pole. A salt bridge. A salt bridge to what? To connect between the two half cells. To connect between the two half cells. The two half cells are separated. Zinc in zinc sulfate, copper in copper 2 sulfate. Salt bridge to connect between the two half cells. Now we will watch a video that illustrates the reaction takes place in Daniel cell. Zinc oxidizes and it changes into zinc ion, while copper reduced and it changes into copper metal. Zinc ions can move freely in a solution as you see. Zinc changes into zinc positive 2 plus 2 electron, while copper positive 2 plus 2 electron, it changes into copper solid in a process called reduction, while zinc changes into zinc positive 2 in a process called oxidation, as you see. And the electron can move freely from zinc electrode to copper electrode. Why? Because zinc loses electron and the electron forms or arises on zinc. Zinc take a negative sign because it is a source of electron. Zinc loses electron and the electron moves from zinc to copper. Zinc electrode becomes a negative charge, negative electrode, and the anode. The oxidation takes place on the anode, while reduction takes place on the cathode. Okay, again, oxidation always takes place on the anode, while reduction always takes place on the cathode. Now we will identify the reaction that takes place at anode and the reaction that takes place at cathode. At anode, zinc oxidation changes into zinc positive 2 plus 2 electron. Again, zinc oxidation process changes into zinc positive 2 after losing 2 electron. At cathode, Cu positive 2 plus 2 electron reduction in a reduction process to form Cu0. Cu0 precipitate on copper electrode and increase its mass. What about the total cell reaction? What about the overall reaction in this cell? Zinc plus Cu positive 2 to get zinc Zn positive 2 plus Cu. The flow of current is stopped between the two half cells when all of zinc metal dissolves in the zinc half cell. Again, the flow of current is stopped between the two half cells when all of zinc metal dissolves in the zinc half cells. Okay? Or all the copper ions disappeared because they are precipitated as copper atoms in the copper half cells. The diagram or the cell expression of this cell. What about the diagram of this cell? The diagram represents the cell expression to know what about the anode, what is the anode or what is the cathode, and the direction of electron. Again, the diagram represents the cell expression. Cell expression means to know anode, to know cathode, to know the direction of the electrons, to know anode, to know cathode, and the direction of electron. Okay, zinc Zn slash Zn positive 2 means zinc loses 2 electron and it changes into Zn positive 2, which moves freely in the solution. X molar specific molarity in a specific molarity solution. Okay, double slash that represents a salt bridge, Cu positive 2, X molar, Cu. This means zinc electrode anode while copper electrode cathode. If you see this structure that represents a diagram of any galvanic cell, you know the anode, the cathode, the reaction that takes place in this cell. And can he ask you to write the reaction that takes place in this cell, or from the reaction you can write the diagram. The diagram of the cell represents the reaction, oxidation reduction reaction, and the reaction can be expressed by a diagram. Okay, zinc changes into zinc positive 2, while zinc is copper positive 2, it changes into copper. Okay. The single bar indicates a junction between the electrode and the electrolytic solution of its ion. The double bar indicates a junction between the two solutions in the two half cells salt bridge. Okay. Oxidation process occurs always at the anode. Oxidation process occurs always at the anode. Takes place always at the anode. While the reduction process takes place or occurs at the cathode in the electric cells. Electric cells, not galvanic cells, in all types of electric cells. Salt bridge. What about salt bridge? Salt bridge connect between. Salt bridge connect between. What about salt bridge? What is the structure of salt bridge? A glass U-shaped tube. A glass U-shaped tube filled with a strong electrolytic solution, like Na2SO4. What about this solution? Its ions don't react with the ions in the two half cells. Don't react with the ions in the two half cells. Means inert solutions. To connect only, not react. To connect between two solutions, not react with any types of ions in a solution or any types of electrode. Its ions don't react with the ions in the two half cells, as well as with the electrode materials of the galvanic cell. What are the functions of salt bridge? Function of salt bridge. Firstly, number one, it connects between the solutions of the two half cells. Indirectly, we know that salt bridge neutralizes the solution of the two half cells when zinc ions increases and the copper ion decreases in the half cell of copper, in the half cell of zinc. What will happen if I exchange N2SO4, sodium sulfate, by barium chloride? We know that barium chloride reacts with sodium sulfate, any solution that contains sulfate, and form a white precipitate, which is BaSO4. BaSO4 is a white precipitate and can't connect between the two half cells. So the oxidation and the reduction reaction will stop. The current flow will stop. Okay? Again, if you exchange sodium sulfate, sodium chloride, potassium chloride, a solution in a salt bridge, by active solution, a solution that reacts with the solution of the two half cells, what will happen? This solution will react with the solution of the two half cells and form a precipitate, which is a white precipitate, barium, Ba positive 2 plus SO4 power negative 2, to give in a ionic equation to give BaSO4. BaSO4 is a white precipitate, insoluble in water, insoluble in hydrochloric acid. Okay? Attention please. It neutralizes the excess of both the positive and the negative ions, which forms in the solution. The two half cells as a result of the oxidation and the reduction reaction in zinc and the copper half cells respectively. Number 3, the absence of the salt bridge. The absence of the salt bridge in the galvanic cells lead to stopping the oxidation and the reduction reaction. Stopping the oxidation and the reduction reaction will stop the flow of current, consequently stopping the flow of electric current. Okay, in the external wire connecting between the two half cells. As we came to the end of our program, I hope everyone found it interesting and had a good time watching us. Thank you, and till we meet again, it's a goodbye. I wish you the best of luck.